Okay, so for today's demonstration, what we're going to be talking about is terminal velocity. For an object that I drop, like this balled up coffee filter, it's experiencing free fall, or honestly close enough to free fall. Free fall is what happens when something is falling and the only force affecting it is gravity. But in the real world, that's not what happens. Even for that balled up paper, it's not what happens. Technically, there's a little bit of air resistance that slows it down. For most objects, that air resistance will slow it down, but it doesn't affect things tremendously. But I came to the top of this very high ladder, and I've got some not balled up coffee filters up here to drop, and let's see what happens. Obviously, you would expect it to be different. And it takes considerably longer to hit the ground. Of course, right? What's happening is the air resistance is slowing it down. It's another force acting on the filter. And so when it falls, gravity is being counteracted, not entirely, but mostly. And so it's falling at a much slower acceleration. But what we're here to talk about is terminal velocity. Terminal velocity happens when the force of air resistance cancels out the force of gravity. So that is to say that when air resistance is big enough that it's no longer accelerating. Gravity doesn't overcome the air resistance, so there's no more net force, and any time that there's no net force, there will be no acceleration. So whenever I drop one of these paper filters, it will accelerate until it reaches its terminal velocity. And that terminal velocity is the speed where the air resistance cancels out gravity, so it stops accelerating. This time, if I have two filters stacked together, its terminal velocity will be different. That's because gravity is larger, and so you would need more air resistance to completely cancel out the gravity, and so it would have to reach a higher speed so that there would be more air resistance before it stops accelerating. So the terminal velocity can be different depending on the size of the object, the weight of the object, the shape of the object, and all of these factors that contribute to that air resistance force. Even the speed that the object's falling affects air resistance. So the terminal velocity is just the speed where it's falling so fast that the air resistance completely cancels out gravity and it stops accelerating.